Great. Let us move on to introduction to databases. Before we even talk about the idea of characteristics of databases, let's just get comfortable with what databases literally are, because I've realized that sometimes that definition in and of itself can end up making us not understand the rest of the information. So databases are literally where we store and manage our data. And in this particular case, let's keep towards the idea of structured data. We already looked at the idea of structured data when we were looking at the example of Excel. And by structure, we just mean the whole idea of rows and columns. So that then makes our data be able to have structure to it. So our databases are many. We could literally call Excel a database depending on how we are using it. So it's all contextual. But nowadays, Excel doesn't cut it. Why? Because it's limited. In as much as you have dealt with Excel with a lot of rows and columns, it doesn't mean that they're infinite. There's actually a limit to it. And the bigger the file system, the file itself becomes, depending on the machine you are using, its processor power, its RAM, and so forth, Excel does start to do what is called lagging, which is literally slowing down and freezing. And before you know it, it might actually be unable to run on your machine. That's where we have to come to the idea of the proper databases, which are then what you then call database management systems, or you always see DBMS. Don't let this ever intimidate you. It just stands for database management systems. And part of these, we've got the open source, the most popular, which is literally my favorite because it's easy to teach. I don't need to buy any software, which is called MySQL. There's also another popular one, which is the SQL Server by Microsoft itself, which has got very cool free features, and then you can also go to the premium one and so forth. This one totally free, which is good. Basically, now the idea behind these database management systems is that they are then able to hold much bigger sets of data than what we can do using traditional items like your Excel in everyday life. So this then supports efficient access and integrity of the data. Integrity, as we once talked about, the idea that this data is not being changed unceremoniously by unauthorized individuals. Access, obviously, is us being able to get access to this particular data to see it, so to speak. So database systems, if you are finding it a bit hard for you to picture out what they would look like in real life, just think of Excel. Because in all fairness, they look like that. It's all literally a bunch of rows and columns. Remember, I did give a disclaimer and said I'm going to focus right now on structured data. Why I'm doing so is because I don't want the nitty-gritties of the information to then get us lost in translation, because there is also now new forms of database management systems which do not follow a structured format by virtue of the fact that some of the data we collect nowadays is different. For example, comments on social media, that then becomes unstructured data, and by virtue of it being unstructured, we can then have columns and rows because it's not structured. It's literally like paragraphs of text. Now that then makes us have to need a different type of database systems to deal with that, which then for lack of a better name, they literally called it NoSQL. We'll talk about the idea of SQL soon, which is a very interesting idea. We'll also have very interesting practicals later on in our course that require these. But otherwise, this is what we are talking about here. Just to get the idea of SQL out of the way first, SQL then stands for Structured Query Language. Structured query language literally feeds into the idea of us querying or asking more information from our database itself. Now, SQL is a programming language which is literally used to query the data that is stored in our database system. It literally can only query structured data that is arranged in rows and columns. It can do that to data that is not in a structured format, like paragraphs of text. That's where SQL draws the line. That's why a new technology, due to the fact that we have a lot of new technologies, that have a lot of new data that comes in that doesn't obey the traditional structured idea, we then have to have a new technology which then also doesn't obey the traditional structured manner. And we then called it NoSQL to really bring on the idea that we are no longer looking at structured data and we are now ignoring the idea of structured data. So NoSQL is literally like yin and yang with your SQL. It's, they balance out each other, so to speak. So now that we've looked at the idea of databases and their importance into our normal way of life in today's technologically fast-paced world, we can then now be able to discuss the characteristics of a good database management system or a good DBMS. Now, a DBMS ensures data integrity. Data integrity means data is not being changed unceremoniously. Any change is being done to the data is being done by authorized and authenticated users. Authorized means they've got the authority to do so by virtue of their position, probably in our company. Authenticated means they have actually gone through the security measures to be recognized as who they are and then being given the permission to do those particular actions they might want to do to the data itself. Then we, a DBMS, another part of it, it should be able to control concurrent access, which is exactly what we named earlier on as a weakness or an Achilles heel for Excel. The idea of concurrent access is the idea that as we are writing data to the database, we should also be able to be reading data from the database. We should also be able to be deleting data from the database. The best way to think of this is to look at an example such as an online store. My favorite in South Africa, obviously, being Takealot. I'm a fan because it's a South African thing, so I hope they make it. I'm tired of all these international oligarchs making more money out of us. So Takealot has a lot of online transactions happening by virtue of who they are. They obviously have to store all that information in a database. You wouldn't want to store that in an Excel spreadsheet because you won't be able to do all these things in a live manner. Live manner literally now means as Evans is buying, someone is returning, someone is just checking, and so forth. A lot of transactions are happening at the same time. Someone is actually signing up to Takealot and so forth. All this information is being collected and stored in a database management system. I wouldn't know what Takealot uses, but obviously they have one and it has to be very robust. Otherwise, it would crash. There's a lot of transactions happening at the same time. I'm sure you can just imagine it. So if this was to be a machine, if this was to be your machine, it would have to handle literally 1,000 of you using this very machine at the same time. Obviously, this is very difficult to do. So we wouldn't imagine a situation where your normal computer is being used by 1,000 users at the same time. But in real life, when we're talking about something such as an online store like Takealot, this actually really does happen. There is thousands and thousands of buyers and sellers and so forth interacting with each other on Takealot. All this information needs to be stored and needs to be stored properly, and it also needs to be managed. That's where the DBMS comes in, the database management system. Okay, so it then controls concurrent access, meaning others are doing whatever they are doing, it doesn't affect what others are doing as long as the database management system is able to handle. For it to be able to do this, it also has to be able to handle a lot of transactions at the same time without crashing. Because once it crashes, everything goes to flame, just like what happens when you try to overwork Excel. So that's why it's very important for us to put a very good demarcation between the importance of database management systems as opposed to more traditional ways of looking at data, which we're used to for personal purposes and for small business purposes would literally work wonders, like your Excel. Now, with that being said, we're then able to then realize the fact that also database management system then supports what is called backup and recovery. Backup obviously is the idea of us actually having a backup of our data. This is literally a spare of our data, just like a spare wheel on your car. And just like your spare wheel on your car, you never realize how much important it is until you need it, especially in the middle of nowhere. For most of the year, I haven't used mine, I think, in 3 years. On that. But, the day I need it, I know it's there. It's right there under the car, and I'll be able to take it out and use it, I hope. Backups obviously help us a lot in the idea that something could happen to our data. We could get hacked. Let us never be naive in this world. Literally, especially in this world with AI and a lot of cybersecurity threats and so forth, things can happen. They say the road to hell is filled with all good intentions. So sometimes you could actually have an overzealous, maybe intern or new worker who's trying to work in the database, and something happens. They press something and clear all the transactions in the database. Now, instead of us just then focus on firing him, which normally is what most people just jump to, which won't solve a thing. We should have a system in place that is able to say, okay, even if there was a mistake, or even if we were hacked by at any point, we can get back the data. And this is then the idea of database backup. Database backup in itself, when this is being implemented in real life, is something that can be built into the system itself, which it can then have rules that determine when it does it. A lot of companies that close on Friday normally then start their backups soon after they close. If you can be able to lose a week of work. For some companies, this is not something that is also possible to happen. So the different ways of database backing up depend on context. Certain companies can actually be able to lose some data without really losing too much of their reputation. While companies literally like yours might not be able to be that flexible, you would need your data as live as possible. All this then determines how much you do in terms of the backups, how often you do it, and so forth. From a week to a month to down to literally milliseconds, literally replicating your real database right now to a backup as you are feeding it. So database is here, DB1, and then you have DBB for backup. So depending on whatever time you could then have the time period that passes as you are doing this copying from live, which is more expensive because now you always need to have ×2 of these ones, which is literally the comparison of having 2 cars in your garage. If one of them wakes up not working well, you can jump into the other one, but also you have to pay for the extra car itself. Or you could have this happening not so often, which is literally then the equivalent of you having a car and also having access to a car hire company. So you could, at some point, require maybe a bigger vehicle, or yours is broken down, or whatever the case might be. That's the same idea with database backup. So once something then goes wrong to the original database, we can then bring this one to the live version. This can be done so fast that even users won't even see that something had gone wrong. So that's why it's also important, because that's the whole point. Once our users see us suffering, they won't see us in the same light. So we always should be able to be available to our users when they need us. So it's very important then to have a backup so that if something happens, we can easily switch to the backup and they don't even see that there was something that happened. But obviously by laws such as POPI Act, we might need to announce those particular things, though the users themselves won't really see the effect, which is very important. We also have the idea of recovery. So backup is what we have like our spare wheel. Recovery is literally the time it takes to remove the spare wheel from wherever it stays in your car to literally fit it where we have a problematic wheel. So the idea of recovery also can't be separated from backup, because it's one thing to have a backup, it's another thing for the backup to be back online as fast as possible. So I've had situations even in the past where I had a backup, for example, of my applications on an external hard drive. And then when I tried to use them later on, I then realized that they are now corrupt, or the external hard drive itself is no longer responsive. So in as much as I had a good idea to keep a backup, the backup itself didn't back me up at all. So it's very important to actually make sure that the backup and the recovery systems are well-oiled machines, so to speak, and they're able to come to our aid when needed. So backup is spare wheel, literally a spare database that has all the information that you need. Recovery is then the process to literally take this backup and make it the useful one. Without this particular smooth transition, we can actually end up being caught unawares by our problems and losing our reputation. Now, the next thing that we need to know is the fact that a good database management system should be able to have security rules. Security rules are literally just like in real life, the rules that we have, for example, at our office here, everyone has got a tag that then gives them access, for example, to the parking, and everyone also have had their biometrics taken. They can then have access to certain rooms or certain part of the office by scanning their face, putting their fingerprint, and so forth. Obviously, this is very important because, for good reason, literally, someone obviously without any server knowledge should not have access to the server room. Obviously, then the server room's entrance gate has got security features that then determine and allow to pass only people who have been allowed to pass there. So in as much as I can walk through the main door of our company, I cannot just willy-nilly end up in different offices or different certain rooms, not because they don't trust me, but because literally I have no business being there, and my all good intentions or my roaming around and curiosity could actually end up with me pressing wrong buttons and ending up with our company in flames. So a database management system also should be able to enforce the security rules. And it will come back to the use of what we did talk about a little bit earlier, which is the idea of what we call, give me a second, my computer sometimes takes time to change into what I wanted to change into. All right, what we call RBAC, role-based access control. So RBAC is role-based access control. So meaning according to your role, then you have access. So a lot of people end up then confusing these two authority. So you'll find some CEOs who won't really like it as you're setting up, because I also consult in my spare time. So as you are setting up these rules, for example, for the server room and for database systems, you always have the traditional bosses, so to speak, wanting access to everything, because to them, by being the boss, they should have access to everything. In a traditional way of speaking, yes, but in a technological way of speaking, hell no. Your access to certain portions of your company should be determined by your roles. A CEO with no knowledge of networks and so forth has no business in the server room. Yes, they can hire an administrator, but they don't even need to go in it without an administrator present. Though that might sound a bit anti-intuitive, it's literally for the best purpose, because with all good intentions, you could press the wrong button and in a puff of smoke, your server is gone, which then is not something we would want to happen. So the idea of security rules is not just security from external threats. We're talking about even security from internal threats, and some of whom could actually have good intentions. I'm sure you've heard this happen. Maybe some of you as we speak, you have phones which are cracked, not because you were careless, but because, like me, you have a toddler around, and those rascals are very hard to, control. I wonder where they get the energy, the energy is just too much. So same thing with our database security rules. We need to protect our database, not just from external threats like your hackers, but also from internal threats like people trying to do something and then they mistakenly delete certain entries in that particular database. So all this is then determined by RBAC, especially for the internal purposes. And then we also have other things such as your firewalls, which then literally securely manage who can then be able to access this database over a network, over the internet. Some databases are so protected that you don't have direct access to the database from the internet. So first of all your queries have to go through certain other applications which then test for everything before your query can reach the database itself. All of this is meant to secure our data from people who might want to cause us harm. And then we can also even limit the number of transactions that a database is able to handle concurrently. This also helps us be able to get rid of what are called DOS, distributed denial of service, whereby our enemies could actually hack 1,000 computers and then use those 1,000 computers, in this case they are now called zombies, to attack our database. So now our database is handling transactions thinking that these are real customers. Maybe there's a promotion happening and it's sweating and crouching and everything like that, yet it's just zombies there to slow down the database itself. So by virtue of us knowing how many people have access to the database, by default, we could also know how many transactions per minute or per day or per hour this amount of individuals should be able to give to this database. So once we start seeing 1 million transactions per minute from a user base of less than 10 people, we would then be concerned to say, how come there's 1 million people logged in, yet we only have 10 people who should have access? At that point, we can then discover for real, we have been hacked and we are now under a distributed denial of service, which is a very, very a powerful way to disrupt the services of your enemies using technology itself. So database management systems, they also are able to enforce that, because you can give them rules to say these are the ground rules, and once something falls out of this, either stop it automatically, such as if someone is trying to enter an email address without the @ sign, it will say nope, that is not an email address, correct it before you enter it. Or we could also have them giving a notification so that in case maybe it's something that's happening and we should know that it happened, but it's not something that's so much of a train smash, we can then have a notification that goes to the administrator, who can then take note of it and see what to do in the future. That's what we mean by database management system being able to enforce security rules. And lastly, a database management system should support efficient querying. Querying literally means the whole idea of us sending our requests to the database itself. Whenever you log in, for example, to a site such as your Takealot, you can actually be able to see, for example, your orders. Your orders are stored in a list, and this list exists in the database itself. As I'm seeing my order, someone else is also trying to check out. And for them to check out, they need access to things such as, credit card details and so forth. And all those are also stored in the database management system itself. So all of those are stored in the database. And the database management system has to be able to handle all that. Database is where the data is. The database management system is the system or the set of tools that makes us have access to the data that we have stored. The two can't really be separated. Now, by efficient querying, we mean whenever then we're trying to look at our orders, we shouldn't have the database crashing or being so late and lagging and giving us maybe too old information and sometimes not giving us enough information. All these things should be dealt with. So the database management system should be able to give us efficient information as we need, as fast as possible, as accurate as possible, without downtime. I hope this makes sense. Let's meet on the next one.